Hi guys, Mr. Thompson here with lesson number 4, and today we're going to be looking at stretching and springs, so the diagram is a bit apt today. First of all, just remind you that you should have completed the vector assignment, the quite difficult one. I haven't got them all in yet. I've made a separate video just to explain how to do it because some of you found it tricky. I've sent that to the boys who have submitted the work already so they can see how it's done. As the submissions come in, I'll send you a link to that. As always, this video and others are on the YouTube channel. And the video to watch today is the Fuse School Springs. It's an excellent video, about 5 minutes long. I would suggest that you maybe watch that first by pausing this and then come back to this if you haven't done so already. Okay, so checking the spec. I ain't going to read this to you. There's about 3 slides. You can pause and look at it and come back to it later if you want to copy some stuff down. So you'll be looking at this equation. And then finally, another equation. So from the spec, my lesson objectives today are that you will know what effect forces can have on objects. You will be able to describe the difference between elastic and inelastic deformation. You'll understand something called Hooke's law. You'll be able to recall and use this equation. And you'll be able to use the equation here, which calculates the elastic energy stored in a spring. Okay, so the first two first, the effects of a force. Quite simple, the easy bit first. Okay, to change the shape of an object, you need to apply 2 forces. Here are some examples. I'd like you to pause it and write these in your book. You can see that the bending, twisting or stretching involves 2 hands. You can't do it with just one. You need 2 forces, a pair of forces. The next objective was what is meant by elastic and inelastic. So here's some rubber bands. As you all know, if you stretch a rubber band and release it, it will return back to its original shape and size. That's why it's also known as an elastic band, because this is elastic deformation. It returns back to its shape and size. However, if you get some things, you stretch some objects, they no longer return to the original shape or size. This is not elastic. As a kid, I used to have a toy called Stretch Armstrong. I'm not sure if you've seen them. And if you stretch it too far, which you shouldn't be able to really, it stretches like the picture on the right. And this is called inelastic deformation. If you stretch it beyond a point, it won't return to its original shape and size. You may need to make a few notes just to explain the difference between the two. Okay, a bit more tricky now. We're going to learn about Hooke's law and we're going to be able to look at the equation. If you watched the springs video already, then you will have some idea about what this means. So many elastic objects obey Hooke's law. Hooke's law states that the extension is directly proportional to the force applied, provided that the limit of proportionality is not exceeded. That sounds quite a lot. It is very, very important that you write that in your book. In the spec, it doesn't refer to it as Hooke's law, but the spring law, but it is very, very important you understand that. And this is just a slide, a screenshot from the Fuse School video, just to explain that. If you look at this carefully, it shows that every time you add the same force, you get the same extension. So starting with 6 centimeters as its normal length, if you add 2 newtons, it goes to 8. That means the extension has gone up by 2 centimeters. If you add 4 newtons, so another 2 newtons, it goes to 10. So it's extended by another 2. So the overall extension would be 4 from 6 to 10. And for 6 newtons, it would go from 6 centimeters to 12. So the overall extension would be 6 centimeters. This means for every 2 newtons, you get 2 centimeters. So we'd have a spring constant of 1 newton per centimeter. To explain that, you could run the graph. This graph isn't for that spring, but it shows you the straight line bit up to the limit of proportionality where it obeys Hooke's law. So you can see that each point is on a straight line, means that for every increase of weight, you get the same extension. Put this into an equation, and you get force equals spring constant times extension. Here's the symbols. F is K times E. This equation you must write down, so you can pause the video and write this down in symbol and word form. And it is one you need to recall, one of the many equations, the 20-odd equations you need to remember and learn for the exam. Okay, you will also at high level need to rearrange it. So K would be F over E, and E would be F over K. You make a note of that, please, because your assessment today will be using these equations. Okay, give you some examples. What force is needed to stretch a spring with a spring constant 10 Newton per meter by 2 meters? Put in the equation. You'd get a mark in the exam for remembering the equation. Put in the numbers. Put in the right answer with the correct unit. Often that would be worth 3 marks in an exam, remembering the equation, using it, and getting the right answer with the right units. For example, if you are going to rearrange it, then E would be F over K. So in this situation, the force is 5 newtons and the spring constant is 10. Divide one by the other and you get 0.5 meters. And then the last example, I've got a force of 20 newtons, and if it extends by 20 centimeters, what's the spring constant? Please don't get caught out. Firstly, you must convert the centimeters into meters. So 20 centimeters is 0.2 meters. Then you can put in the equation and the numbers, and you'll get 100 newtons for every meter. And remember, this equation only works within the limit of proportionality. Once you go beyond that point on this graph, it will no longer obey Hooke's law, so it doesn't apply. Okay, probably the hardest thing today, actually, higher level, be able to use the equation EE equals half KE squared, which calculates elastic energy stored in a spring. So here's an example, just so you can see what it means. To stretch a compressor spring, you must do work. This means you increase the elastic energy stored E. So if you look at the diagram above, pushing the ball back into an elastic gun, the ball has elastic energy. The spring stores elastic energy. When it's released, it can turn into kinetic energy. Okay, to work out elastic energy in that gun, you'd use this equation. Just to explain what this equation means, you are given it in the exam. You do not need to learn it. It's given on a sheet in the exam. So the capital E always means energy, and the little e next to it means elastic energy. That's always measured in joules. Energy is always measured in joules. K, just like the last equation, is the spring constant, newtons per meter, and E is the extension in meters. Okay, give you a few examples, or before I give you a few examples, rearranging the equation, a bit more tricky now, you get these two equations. Worth noting these down in your book as well, and you will need them for the assessment after this video. Okay, two examples. Calculate the energy stored in a spring constant 10 newtons, stretched by 0.2 meters. Write the equation, write the right answer, the right numbers in, and you will get the answer and put the right units, joules, on the end. You may want to write this in your book as an example. Okay, example number 2, if you're going to rearrange it, calculate the spring constant of a spring which stores 100 joules of energy when stretched by 0.1 meter. Rearrange the equation, as I showed you, put in the numbers, making sure you square the extension there, and you should get an answer of 20,000 newtons per meter. Okay, the last one, which was rearranging to get E, is quite tricky, and there's some examples on here. So to finish off today's lesson, you've made some notes, hopefully you've understood what I've said, and now to practice using the equation, you're going to go over to the Microsoft Forms again, and you will do this. Please take your time, doesn't matter how long it takes you. Have a pen, a pencil, a bit of paper, have a calculator with you, calculate the answers and put the right answer in. And hopefully you will get 10 out of 10, and I'll see that and be able to give you feedback. Okay, it's a bit of a longer video today. Hopefully you've made the notes and understood what I've said, and have a good weekend once you've done the assessment. Bye for now.